Hello, can you hear me? Yes. I must admit I was following the first 5 minutes, but then I couldn't understand most of it, although this is my 5th time in IAS. So first of all, thank you very much for the invitation to give a keynote presentation, and I'm really glad that I'm among yourselves. The next 40 to 45 minutes presentation will be mainly for connecting some concepts within the prefab and modular construction. So the title of the presentation is Transforming Construction through Prefabricated Systems. And the whole idea is to change from the on-site construction to the off-site manufacturing. I'm just going to wait for a second just to fix this monitor. I still can see mine though. Good, thank you. So, starting the presentation, I would like just to clarify that I will be talking quite a lot about modular construction, and prefab and modular, as you know better than me, they both fall under the same umbrella. So they both have an element of customization, but the degree of customization is different. When it comes to modular construction, the customization is more because usually bigger systems, they come all the way straight to the site as opposed to the prefab concrete elements. And I'll start the presentation with some facts. So despite the fact that we've been working for over 15, 20 years on sustainability, so the sustainability word is quite common, still we use quite a lot of material in our designs. From a recent study in existing UK buildings, we found out that more than 46% of the building's material used was not needed. Although we use all these nice new tools for optimizing our structures. At the same time, we know that more than 10% of the carbon emissions are coming from the construction sector. So we're not doing that well, I must admit. And one of the other key kind of identifiers is that more than 93% of the material that we produce, we then recycle. And recycling itself is a very energy-intensive process. So although, again, we've been talking the last 5 years or so about reusing, we don't really think about reusing that much, and we always quote all the difficult parts about reusing, and that's why we don't go for it. So the challenges that we face today are categorized in these 4 different sections. So we have the project planning and the cost overrun. That is usually a case, especially when it comes to slightly more complicated structures, let's say, any kind of structures from buildings to infrastructure projects. It's the non-conforming materials with the standards. The standards are changing, the materials don't really follow up all the time. And the great example was the Grenfell Tower in London, where we had these facades being used for more than 1,000 buildings, and we found out that finally they're not qualifying the performance of the material. The reduced quality and the workplace productivity, which is a big thing, we'll see it also in a minute, and there are again quite a lot of delays, and the safety on site. I must admit that we've been doing better when it comes to safety, but still in large projects all around the world there are still fatalities, people are losing their lives. So McKinsey back in 2017 got all these kind of studies, and they came up with this very nice 3-pillar sort of like way of promoting the construction sector, which is categorized by the digital design and engineering, the new materials and systems, and the advanced manufacturing automation. They said that if we solve this triangle with new disruptive technologies, then we can talk about a new version of the construction sector. So this transforming the construction sector must be done in line with this, and the productivity in our sector will also increase. At the same time, we are facing a huge housing demand, especially in the mega cities and the large cities of the world, where the small plots of lands are too expensive and we want to accommodate more and more people because more people are getting into the big cities, you can see always that buildings are becoming higher and higher. And the funny thing is that nowadays it's also residential buildings. In the past it used to be more commercial. But of course, in the city centers, we also need to accommodate people living there. So this is not only happening in the mega cities of the world, but it's also happening in other large cities. For instance, Leeds is a 800,000 people city. It's the fourth or fifth biggest city in the UK. It's definitely not a mega city. It's just a large city, anything above 250k population. And you can see what is the projection of the population over the years. So 2039 is the last year on the graph, and you can see how much is increasing. It's linear, it's not exponential, but it's increasing with a very steep curve. And you can see from a picture that is taken in the city center, only within 2 years, how the skyline of the city center has changed. And my friends in Leeds are telling me that this picture is now outdated, the one in 2019. You can see more tall buildings in the city center. So my presentation is more about buildings, but buildings are built on the infrastructure projects. And we have to think about how the ecosystem of the entire infrastructure is promoted in a way that we do build better. So buildings, why buildings are important for me? Because we spend quite a lot of time in buildings. I don't know if you have actually seen how much time, if you've seen studies that we spend in buildings, people don't realize, but more than 90% of our time we spend it in buildings. So from the moment that we are born in a hospital, we move to a nursery, we go to kindergarten, primary, secondary school, we go to universities, we go to our jobs, our houses, we spend all our time in buildings. Even when we say, I'm going to go out, most probably you go out and then you enter another building. That is for a restaurant or a cinema or whatever. So we do not think that much about our buildings, but we think more about our cars. We change our cars every 5 years. We want to have smart cars. We want to have the new cameras, the new systems, ecosystem, everything. But we don't really change. Our buildings are outdated. So I just did a very simple search to find what is a building, what is the definition of the building, how we should think about buildings. And of course I started with Google, and Google gave me just a very simple answer. It's a structure with a roof and walls. And I guess pretty much all of us will think about buildings like that. When I used ChatGPT, we live in an era of AI, so I must use ChatGPT to give me this always 15, 20 lines explanation, what is a building. It came with a far more elaborated response. And I highlight that the building is a shelter, is for protection and for storage. So already 3 different functionalities for what buildings are. It's not just our house, right? And at the bottom it says something very important. Buildings play a crucial role in shaping the urban environment, providing spaces for people to live, work, gather, and carry out numerous activities that support human civilization. So it takes it to another level. So buildings are supporting our human civilization, how we age, how we live in that era, is related very much to what buildings we've got. And of course, if you look at the history, you will see that buildings have been completely different all the time. So then I asked Midjourney, which is the ChatGPT's picture, sort of like AI, and it came up with this kind of building, which I know that this is a very futuristic sort of explanation of what a building is, but buildings being built like that in the near future. Already planning of buildings like that has started. And this is a multifunctional building. So when we talk about buildings, we should not just think about a few walls and a shelter, but we should think about all the other activities that can happen in those kind of structures, and how that kind of structure is related to the suburban area, the infrastructure that comes with it, etc. Now, let's see where we are. In the past, like 200 years ago, in the UK, an architect created this Gothic style building, right? So back then, the architects were paying a lot of attention in detailing, and they made these amazing buildings that we want to preserve. The difference back then and now is that, first of all, we were taking a lot of time building those buildings. These buildings were not built in a few months. And of course, these buildings were very fixated in their usage. So very fixed purpose buildings. They were made to be hosting people and that's it. Not multi-purpose, not changing over time. So we can't do much about these buildings. These buildings, as you may know, these are listed ones, so we should not touch the facade. Sometimes nowadays we demolish everything inside and we build a new structure. It's quite difficult and it's quite also energy expensive to do that. So most of these buildings, they are very, very simple, like hotels. We use them for hotels, like very simple usage. Just to think, these kind of buildings, they don't even have lifts. So we're talking about a completely outdated structure with a nice facade. But let's see how we're building like more recently. 50 years ago, as you can see the one on the right at the back, we built that kind of building. Is this a building that it's an architectural pleasing one? Most probably not for the moment, not for now. Okay, so I'm talking about the one on the back, on the right. What about this building? This is a brand new building. It's been built last couple of years. It's a nice one. You can tell that this is a minimalistic architecture. You can see through the windows and you can tell that definitely it's a nice interior. But I'm not sure if that building in 50 years from now will not look as ugly as the one on the right. So most probably that building in 50 years, you need to do something with that. And we haven't thought about this when we did the initial design of that structure. So let's see some like more important buildings, like tall buildings, right? More difficult also to change. From 1970s to 2020s, the only difference I see is a slight difference in terms of proportion of volumes. And of course, the cementitious-based facade is now replaced with a glass facade. Such a big deal. Over 50 years of a change, if you put a car 50 years ago and a car now, they look completely different. Now, the nice thing about prefabrication is that prefab projects that always had an element of customization, and they were also used for unique landmark structures. So the lesson is there. We already know that we have used prefab structures for doing these kind of unique things. And it's not only the past. You can see more recent structures that they are from low-rise to mid-rise, even some sort of like tall structures, not skyscrapers per se, but some good-sized structures that they are all prefab. So how the buildings will look like in the future? So if you asked me, I think buildings will look like this. I know, again, this is a futuristic approach of looking like a building, but they will be vertical cities, what we call today vertical cities. We do have this kind of buildings, like Burj Khalifa in UAE is a vertical city. The Shard in London is kind of a vertical city because it's a hybrid system with many, many purposes. It's got restaurants, it's got a hotel, it's got residential flats, it's got offices. So in the future, we need to pay more attention to these things that you see on the right. So buildings, they have to be multi-purpose. They have to be flexible and adaptable structures that we can change over time if we don't want to demolish them 50 years down the line. They have to be easy to maintain and retrofit, something that at the moment we're not really doing very well. And we have to have a capacity to deconstruct in a controlled manner and most probably reuse some parts of these structures. So we should think buildings as live entities. So buildings, they are live. And anything which is live, it ages. So buildings age as well. Like this human being, this grandpa, that is aged over the time. So this man needs this walking stick to walk after a few years. This walking stick, think about it, is like the retrofitting or the stability system that you add to an old structure to be able to change its uses. But why do we need a retrofitting system? We need it because this man has got very stiff and very short joints, very old connections, so he hasn't paid that much attention to his connections. Perhaps he wasn't going to the gym. So buildings are also aging in the same way. We pay far more attention how we optimize the concrete and the steel that we use, how we optimize the members, but we don't pay that much attention on the connections. And as you can see in the pictures, in most cases, these connections have been deteriorated, degraded, and there is also a significant sign of damage, not to mention that one of them has been subjected to fire. So buildings move, and because they move, connections are getting damaged. This is an earthquake in Japan, and you can see that the building is moving. There's also another one next to it. And human beings are moving as well, and we have this amazing capacity to be able to do anything we want. I know that this is a little crazy as a video in such presentation, but what we're trying to do here is to understand what sort of capacity we have as human beings and buildings don't have, get inspired from that, get some of the ideal behaviors of our joints and transverse that and convert it to a simple connection that buildings should go. So our group is designing connections, new type of connections that allow for sway, for movement, for control over the structure, and allow for disassembly and reusability, something that, as I said, we haven't done that much. And a great example is Lego structures. Lego structures, they're amazing. And that's why they patented back in 1960s their connection. And because of that particular connection that they've got, you can do anything you want with Lego structures. And you do not need even a stability system. It's just the Legos sticking to each other, and you're producing anything you want. So again, I would like to emphasize, especially here, because we are doing prefab, that we should be paying far more attention on the connections than anything else to begin with. So when we started, we said, okay, let's look at what is the most resilient, the most robust connections out there, and we came up with cargo structures, cargo containers on ships, because these are very robust. They can do anything you want. I mean, they last for many, many years. And then we tried to improve those kind of connections and understand their behavior. And gradually we went from low-rise buildings to mid-rise buildings and high-rise buildings, trying to improve those. So our portfolio of studies, it had three different key themes. And the first one was the modular and the prefab. Now, why modular? Modular because it's a market that is coming up very aggressively. As you can see now, we're around like the 70 billion market worldwide. And is not only covering commercial, but it's covering hospitality per se, or healthcare, education, and residential structures, as we will see in a minute. UK is one of these countries that is doing a lot of work, but it hasn't applied that much as Japan and Nordic countries have done. But there is a kind of a trick there, because any country that you see that they haven't applied that much is because they are using modular for tall buildings, whereas in Nordic countries and Japan, they use smaller size buildings. So just to put you into the context, the UK precast concrete industry, just in the UK though, worth 6.7 billion. Okay, so we're talking about a 70 billion market for the modular at the moment. I know that precast concrete market is bigger, but of course the modular is one of those that we should not disregard. And you already know what the benefits of modular construction is, that are very similar to the prefab construction. But there are some deficiencies, some barriers in modular. And these are the transportation and logistics, because we have to carry bigger systems now, not just slabs or beams and columns. And the lack of codes, which is something that we also experience in the design of prefab systems. So we need to pay far more attention. Just to give you an idea, in the UK there is a pipeline of 500 tall buildings, I think now it's around 480, to be built the next decade. And 80% of them will be built in London. So there is an element of prefabrication in most of these structures, if not to mention that a few structures are only prefab. And the market is huge. When it comes to modular per se, as I said, we build tall buildings. We are we have this advantage that we don't have earthquakes in the UK, so we can test our tall buildings. Of course, we have significant winds, and all these projects have been completed, and there are many more that are coming up. And this is not the end. We built Modular for other purposes as well. You see the one in Germany that is being used for replacing a steel moment-resisting frame within that old structure with container-like structures, the so-called volumetric structures. So the application of prefab and modular prefab is increasing all the time. Now, another key element in that puzzle is the reuse, as I've mentioned before. Why you want to do prefab? Because you can also reuse. I'm sure that you all experienced that battle, SpaceX versus NASA. NASA, a very well-funded US institution, and everybody thought at the beginning that SpaceX can do nothing, and NASA is the one that we will always follow when we're talking about the space. Yet, SpaceX not only get a front of NASA, but it implied that NASA will have to follow what SpaceX will be doing. Why? Because they came up with a new business model, the business model of reuse. So they had the idea of we can reuse the spacecrafts, and that's why we can beat NASA, in fact make NASA work with us. Now, how is that connected? Modular systems, they are also complex structures, like spacecrafts. They have a number of layers that come together, a high degree of customization, everything has to be perfect and fit each other. When we design modular, we have to design for manufacturing and assembly, for transportation, for installation, and ideally to design for deconstruction as well. So a lot of thinking has to happen at the very early on. And in a recent study we did with my PhD students, we found out that there are more than 60 different connection systems for modular buildings. And that's a good thing. It means that people, they're interested about that, but at the same time is a bad thing because it means that engineers who want to use modular, they don't know where to start. All these 60 joints are all competitors to each other, and there is no standardization. So the final piece in our puzzle was to come up with a solution that is fit for all and can be standardized so we can finally put it into the Eurocodes. And that is when, back in 2018, the 3D MBC project started. It was initially funded by the Royal Academy of Engineering and funded by fellowship, and since then we have been receiving quite a lot of funds. So the aim of that was to develop standardized three-dimensional steel connections for modular buildings that they allow doing all these kind of things that we've mentioned. So we started from the very basic stuff, like sketching new connections and understanding how these modular buildings should be connected, doing quite a lot of optimization studies, topology, material, shape optimization, and then running the generative designs to understand their cyclic behavior and so on. We've done numerous tests at the University of London, but also in collaboration with partners in Australia and China. And at some point we've realized one interesting thing. People have the assumption that modular construction is lightweight, but actually it's not. Because of the fact that, I haven't pressed anything, okay, there are double beams and double columns, ceiling beams, floor beams come next to each other. In fact, those kind of structures are quite heavy. So another challenge that we had was to play with these connections and optimize the weight of the structures. So we did quite a lot of optimization models, and we've managed to reduce, as you can see on the right-hand side, the tall blue and the shorter green bars, that we managed to reduce the weight of the structure by playing with the stiffness and the properties of the connection, something that it was the first time that it was done. Beyond that, we did the minimum weight sizing design of self-standing buildings. So we started designing tall structures without concrete core, because the concrete core is the one that actually it's the time of the construction. So we reduced the size of the concrete core, or we removed it, and we developed a framework study for the minimum weight optimization of such structures. And we recently patented one of our first connections. This is the third one that we patented out of this project for steel modular, and is a hybrid connection. It's made by steel, rubber bearings, A-shaped memory alloys, and it's very well engineered in order to allow for different kind of movements. So this is one of the tests that we did recently, and we've experienced very nice behavior when it comes to the connection between the top and the bottom T's, which were part of the modular, and fully reusable connections. We've done something similar. I'm just going to go very quickly through these slides. For timber modular connections, we found out that one of the main problems in timber is that we needed to have access hole in order to be able to screw those connections. And those plates used so far in all timber, there were the limitation of going to higher buildings. So we've changed that. We came up with a new construction methodology that is empowered by its connections. It's like a dovetail connection, a sliding connection and a sticking at the end. Complete different way of constructing a building, and allows to go for taller structures without the need of any gaps in between. And reduction of these gaps not only improved the acoustic and the thermal behavior, but also improved a lot the fire performance, because you're reducing the gap between, so there is no cavities in fact. And taking that to another level on the connections, and I'll kind of stop with the connections, is to elevate the properties of the connections that for high-rise buildings, and get idealized performance. And because of that, we started using FGMs, functionally graded materials with varying Young's modulus and densities, that they give us different properties, cellular periodic materials, and negative stiffness elements, which are amazing. We've 3D printed a few of those, and we've used them for connections. We just did it in a small scale because they're quite expensive, and we can get some amazing behavior when it comes to dynamic performance of the structure. But connections is one thing. Let's not forget that the vast majority of the weight in a structure comes from the slabs. And I know that you all know that, but a lot of students don't realize that the structure itself, it is heavy because of the slabs. So, and recently WSP actually quoted by the end of the 22 Bishopsgate, this is the tallest with the shard building in London, and they did quote that they managed to reduce 40% the savings of the weight, and the reduction of 1% of EC is equivalent to 100 years of the average UK person. So you can imagine how much they have managed to save. And because of that, we did again very laborious LCA studies, and we found out that if you want to get the best prefab product, you will have to have lightweight, if not ultra lightweight concrete, thin-walled steel elements, so any elements you put in that, they should be as thin-walled as possible, and fully prefabricated systems. And because we focused on slabs, fully prefabricated flooring systems. And on another study, we also found that it's better in terms of the logistics and the installation and construction if you actually put the insulation material within your product rather than putting that on the structure. And over the years, we've done many tests. These are quite old, in fact, it's more than like 10 years ago. But we've done more recently FEA analysis and a lot of tests of hollow core units with topping, without topping, using different products, thousands and thousands of parametric studies to come up with the best solutions. And more recently, that was 2016, we came up with a new prefab ultra lightweight slab system. We call it PUSH. Which is a fully customized a prefab system with ultra lightweight concrete, and it does work, although it's got this very, very light concrete, which is usually not used for structural purposes. And the whole idea is that we came up with a very unique shear connection system that is made by some shear studs as well as some dowels. And we did the prefab, we did the comparison of these prefab systems. And as you can see on the right-hand side of every graph, we managed to actually reduce the sustainability indexes by quite a lot when it comes to the proposed system. So if there is one thing to take out of this, and of course there is more work to be done, is that we managed to reduce the fabrication costs by 35% and the site and erection costs by 65%. And you can go through the publications and find all these papers. And more recently, with some collaborators from various universities, including Cambridge University, we are testing the 3D printed materials and the reduction of the weight of the materials for these kind of slab systems. So we play with all of them. Now, of course, like I think every researcher does nowadays, we also come up with free-form, unique structures for unique applications. So if you want to reduce the weight of a particular very large slab, you can always do some sort of like topology optimization, and you reduce the weight. But of course this means that these kind of slabs cannot be reused, so we don't do too much of that. So to almost conclude about the 3D MBC project, that then it became a program, we focus on these three different themes: the digital design for manufacturing and assembly, the new material systems for testing and certification, and the construction automation and offsite manufacturing, which is very key to all that. And as you all been trying to do in your businesses, we're trying to reduce the construction time, we're trying to reduce the life cycle costs as well as the waste that we've got. And the kind of the projects that we have there is the advanced prefab and assembly techniques, where we're dealing with many different materials, and from panelized to smart ports, connections, anything. We've been advising quite a lot the modular construction industry, and that's the beauty of prefab, because all these solutions, they're not just made by one material, they're hybrid solutions. So, for instance, one of the things that we've been doing lately is that to replace in steel volumetric the timber slabs with concrete slabs, because they have this thermal mass, and although they're a bit heavier, they actually work better in our analysis. And even coming with something like that, like wood concrete hybrid flooring systems for modular buildings. We're working on high performance materials, as you saw before, as well, for the connections. So we're trying to come up with solutions that they are unique and better. As engineers, we haven't done very well the last years. I know colleagues of mine that they've been getting millions and millions of fundings, and still we use steel and concrete out there. So they get all these multi-funded projects for the additives into the concrete, and I haven't seen much in use. So we are trying also to expedite that. We're also doing quite a lot of work on the manufacturing and assembly. So especially when it comes to timber, how we can best manufacture those products. As you also saw before, we do a lot of testing, different kind of testing, and we do collaborate with a lot of universities around the world. And last but not least, we're doing quite a lot of work with the on-site construction monitoring. As we said at the very beginning in the slide, the first slide of the presentation, we're trying to convert the on-site construction to off-site manufacturing. However, there is an element of construction that we need to do on-site always, and we're trying to make it with the use of the digital tools. While I was at the University of Leeds before, a few years ago, I had the pleasure of working with BAM on this Leeds University Extension building, which was full prefab. And the beauty of that building, it's the one that you see in the middle between the two, is that is fully reusable. So, you know, maybe in 50 years from now, it will look outdated and they will want to take down and replace it with something else. And of course, it's achieved very high scores. So modular is at the epicenter of prefabrication, and the modular systems are pretty complex. And the message that I want to give here is that most of these structures are hybrid. So always think about where concrete comes into this steel or timber modular and how best we can use different materials for the best performance. It's not one or the other world, it's not one or the other business. These kind of future buildings will need the collaboration of many different expertises, and thanks to the architects, there is also concrete modular, which are coming up more and more often. Most of them are pretty sustainable, so we use them for different types of structures. And there is also the combination of concrete with timber for taller structures, again something that is coming up, very sustainable construction, as well as the combination of concrete with brick structures for facade, but some of these facades, in fact, they are load-bearing. So don't forget that what we don't see is what it usually matters, and in these kind of structures that they are coming up in Middle East, most of them, and they have a high degree of engineering solutions. So most of these are fully prefab, and one of the takeaways from that is that these kind of buildings, they will need an element of deconstruction and reusability in order to go ahead. Because the way that they're built to begin with, they need that change to happen at some point. Like the line project in Saudi Arabia, where it will happen in segments. So maybe the next 50 years they will be building the line, and in 10 or 20 years from now, when the technology will be completely different, we will need to be going there and changing things that we're doing. So these buildings are not fixed at all like we used to build 200 years ago. And of course, thanks to all engineers for coming up with these amazing solutions, because at the moment, unfortunately, there is very little guidance for prefabrication and modular construction. So if you want to achieve something amazing, you need to study quite a lot. And before I close the presentation, I would like just to give a hint. I think myself doing quite a lot of research on AI, and I'm running a 13 million hub of AI in large cities. I think that there is a huge appetite here and a huge potential for prefab construction to use AI-based solutions because of the high degree of customization and the precision of the product being made offsite. So there is a lot of research that is coming out, and I think some of you may want to watch that and see how you can use those AI-based tools for producing your buildings. And if I haven't managed to convince you by now that modular, it is the way forward, and prefab with modular, they should be working together, maybe this is a halfway through solution where it's coming up in the UK, where there is a hybrid modular structure. Now this hybrid is because part of the structure is permanent and part of the structure is changeable, which means that there will be, let's say, a moment resisting frame, and then you will have a pod of a part of your flat, and you will be able to build to connect it and live there. And you may want to relocate at some point somewhere else. You will be able to take it out because of these amazing connections that they've got. And of course, if you want to move somewhere else, or if you work somewhere else, or if you divorce and you want to take half your house out and move somewhere else, you can still do that. And it is coming, and there are actually even startups that they've come up with these solutions. Unfortunately, I cannot reveal the name of the startup, but they've been building designs that are for fully changeable structures, and the whole idea, their business model, is that you can get a mortgage for half of your flat. So you stick half of the flat there, and maybe 10 years later, when you're like 40, you can get the rest of the mortgage and you can stick the other half of the flat. So these rather crazy stuff nowadays is coming, and I think it will come sooner than later. So I'm closing the presentation with presenting that infographic from from Autodesk that I think it includes pretty much everything that I've been discussing here, the connections, the hybrid systems, the prefab, IoT, and everything, and how the construction will look like in the future, which is a big market. And if you want to see the technical stuff of our work, you're more than welcome to visit our website, 3dmbc.com, or by scanning this. And start reading some of our papers. And last but not least, I would like to thank most of our collaborators. These are the key collaborators, the ones that we have grants together, research grants together, but of course there are many more than these. So thank you very much for your attention. I hope it wasn't too tiring.